If I asked you to name the most heavily armed conventional warship on Earth, you might picture a nuclear aircraft carrier or a guided missile destroyer. You'd be wrong. The largest precision cruise missile arsenal in human history doesn't float on the surface. It hides 800 feet below it. It carries no nuclear warheads, but a single one of these machines can launch 154 Tomahawk cruise missiles in a matter of minutes. That is a payload large enough to single-handedly dismantle an entire nation's air defense grid before the enemy even knows they are under attack. Meet the four horsemen: USS Ohio, Michigan, Florida, and Georgia. They are the Ohio-class SSGNs, and here is a terrifying piece of math. Just these four submarines account for more than 50% of the vertical launch cruise missile capacity of the entire United States submarine fleet. But they aren't just missile trucks. They are submerged five-star ghost bases. They house up to 66 Navy SEALs, deploying mini-subs, underwater drones, and orchestrating theater-wide wars from the bottom of the ocean. But there is a catch, and it is keeping naval planners awake at night. These steel leviathans are aging out, the reactors are getting older, the hulls are tired, and when these four boats are forced into retirement, America will lose half of its stealth strike power overnight. If you want to understand how four Cold War relics became the ultimate shadow weapons, and why replacing them is creating a massive firepower gap that the U.S. shipyards are struggling to fix, stay with me through the end of this episode. Welcome back to Future War Tech. Let's dive in. Part 1. The rebirth of the Leviathan and the mathematics of destruction. To understand how the Ohio SSGN became the most lethal conventional platform on the planet, you have to rewind to the end of the Cold War. By the mid-1990s, the Soviet Union had collapsed. The ultimate doomsday scenario, a massive, civilization-ending nuclear exchange, was no longer the immediate threat it once was. In 1994, the Pentagon conducted a nuclear posture review and came to a stark conclusion. The United States Navy had 18 Ohio-class ballistic missile submarines, but to maintain the nuclear deterrence umbrella, they only needed 14. That left the four oldest boats in the fleet, USS Ohio, Michigan, Florida, and Georgia, without a mission. Normally, in the military, when a platform ages out of its strategic purpose, it gets decommissioned, cut up for scrap metal. But Navy planners looked at these four massive hulls and realized they had a once-in-a-generation opportunity. They didn't see obsolete Cold War relics. They saw unparalleled stealth real estate. In 2002, the Navy initiated one of the most ambitious engineering transformations in naval history. They brought these four boats into the shipyard to strip them of their nuclear missiles and rebuild them for a completely new kind of war. They changed the designation from SSBN, Ballistic Missile Submarine, to SSGN, Guided Missile Submarine. Now, you will often hear naval commentators generalize the Ohio class as a flat 18,000-ton behemoth, but in the world of submarine engineering, that is an oversimplification. When you rip out 24 massive 60-ton nuclear ballistic missiles, redesign the internal pressure bulkheads, and install heavy lockout chambers and specialized seal equipment, the physical profile changes. The mass, the trim, and the overall displacement shift. An SSGN is a distinctly different beast from its ballistic brothers, engineered to balance a completely different payload. And that payload is what makes the rest of the world incredibly nervous. Let's look at the launch deck. The Ohio class was built with 24 massive vertical launch tubes, originally designed to hold the Trident missile, a weapon so large it is essentially a deep space rocket. When the Navy removed the Tridents, they were left with cavernous steel cylinders. Instead of putting one conventional missile in each tube, the engineers designed something called the MAC, the Multiple All-Up Round Canister. Think of it like a massive revolver cylinder. They slid one MAC into each of the empty Trident tubes, and inside each MAC, they packed 7 Tomahawk land attack cruise missiles. Out of the 24 original tubes, the Navy dedicated 22 exclusively to this missile system. Do the math: 22 tubes, 7 Tomahawks per tube. That is 154 precision-guided cruise missiles sitting on a single submarine. To put that in perspective, a standard attack submarine might carry around 12 to 40 missiles, depending on its class and configuration. An REBIRTH-class destroyer has 96 launch cells, but those have to be split between air defense, anti-submarine rockets, and cruise missiles. The Ohio SSGN doesn't split its payload. It is a dedicated underwater missile truck. In fact, just these 4 submarines alone represent more than 50% of the entire vertical launch cruise missile capacity of the entire United States submarine fleet. Half of America's undersea striking power is concentrated in just 4 hulls. This completely changes the way military commanders plan a war. When you have 154 missiles on an invisible platform, you aren't just engaging in precision strikes. You are capable of what strategists call a saturation attack. A saturation attack is simple, brutal math. No matter how advanced an enemy's air defense radar is, and no matter how many interceptor missiles they have, a system can only track and shoot down so many targets at once. If an enemy base has 40 interceptors and you fire 40 Tomahawks, it's a fight. If you fire 154 Tomahawks from a location they can't even see, their system simply chokes. The defense grid is overwhelmed, the interceptors run out, and the targets are completely erased from the map in a matter of minutes. It is the ultimate first day of the war weapon. It kicks down the door so bombers and fighter jets can fly through uncontested. But sheer firepower is only half the story. Because the Navy didn't use all 24 tubes for missiles, they left the first 2 tubes empty for a very specific, highly classified reason. They didn't just want a missile truck, they wanted a ghost base. Part 2. The 5-star ghost base and the silent warriors. If you look at the deck of an Ohio-class SSGN, you'll see the 22 missile hatches we just talked about. But if you walk all the way forward, near the sail, you will find tubes number 1 and number 2. When the Navy removed the nuclear missiles from these 2 forward tubes, they didn't fill them with Tomahawks. Instead, they permanently converted them into lockout chambers. This decision fundamentally changed what a submarine could be. It turned the Ohio class from a pure strike platform into the mother of all special operations bases. Normally, when Navy SEALs deploy from an attack submarine, like a Virginia or a Los Angeles class, it is a brutal, cramped experience. Space is at an absolute premium. Guys are sleeping on torpedo racks, gear is crammed into every corner, and planning operations is a logistical nightmare. The Ohio SSGN is different. This thing is over 550 feet long. It has the volume to dedicate entire sections of the boat specifically to the special warfare mission. It can carry up to 66 Navy SEALs or Marines for months at a time. And we aren't just talking about bunk space. The submarine features dedicated mission planning spaces, weapons lockers, and even specialized medical facilities to treat casualties. Within the special operations community, it is effectively an underwater 5-star hotel. But the real magic happens when those operators need to go to work. To get to the fight, the SEALs don't need the Ohio to surface. Surfacing is the most dangerous thing a submarine can do. It exposes the boat to radar and satellite detection. Instead, the SSGN is designed to carry what are called dry deck shelters, or DDS. These are massive, removable steel pods fitted over the lockout chambers on the hull. Inside these shelters are swimmer delivery vehicles, or SDVs. Essentially, they are mini submarines. While the massive Ohio-class submarine hovers in the pitch black, deep underwater, The SEALs climb up into the lockout chamber, flood it, and enter the dry deck shelter. They board the mini-sub, open the outer hangar doors, and quietly slip out into the ocean. They can transit for miles underwater, hit a hostile beach, conduct a raid, rescue a hostage, or laze targets for an airstrike, and then drive their mini-sub back into the belly of the mothership. The enemy wakes up the next morning with their coastline compromised, and they never saw a ship on the horizon. But inserting special operators is only part of what makes this ghost base so dangerous. The true terror of the SSGN lies in its brain. Because of its massive size, the Navy was able to pack the SSGN with highly advanced communication suites, super high-frequency antennas, and data processing power that smaller attack submarines simply cannot support. It operates as a submerged joint command center. Imagine a major regional conflict breaking out. Normally, a theater commander, an admiral, or a general would operate from an aircraft carrier or a heavily fortified land base. Both of those are prime targets for enemy hypersonic missiles. With an SSGN, that commander can literally sit at the bottom of the ocean, completely invisible. Shielded by hundreds of feet of seawater, they can receive real-time satellite intelligence, coordinate B-2 bombers flying overhead, direct surface fleets, and command special operators on the ground, all without ever exposing their location. It is a floating, untargetable fortress. But the Navy didn't stop there. Because these submarines are so large and so capable, they realized they could use them for something else entirely. Not just a base for humans, but a mothership for the machines of tomorrow. Part 3. The Mothership of the Deep and the Open Source War. When you have a platform this massive operating safely in the darkest corners of the ocean, you don't just use it to fight today's wars. You use it to invent tomorrow's. Despite being born in the 1980s, the 4 Ohio SSGNs have become the U.S. Navy's ultimate mobile laboratories. They are the testing ground for the future of undersea warfare. And it all starts, once again, with those massive vertical launch tubes. Because the original Trident missile tubes were so wide, the Navy realized they didn't have to be limited to just Tomahawks. The tubes are effectively payload agnostic. Today, the Navy is using that cavernous space to turn the SSGN into a mothership for unmanned systems. From deep underwater, an Ohio SSGN can open a hatch and deploy UUVs, unmanned underwater vehicles. Think of them as autonomous drone submarines. The Ohio can sit in the safety of the deep ocean, hundreds of miles away from an enemy coastline, and release a swarm of these UUVs. They swim forward into heavily defended, shallow waters to hunt for sea mines, track enemy submarines, or gather acoustic intelligence, beaming that data back to the mothership. They can even launch UAVs, aerial drones, shooting them in capsules that float to the surface, breach, and take to the sky, suddenly giving the submarine its own radar and camera feeds high above the clouds. It is essentially an underwater aircraft carrier for the drone age. But to control a swarm of drones, process satellite data, and track hundreds of targets simultaneously, you need immense computing power. And this presents a massive engineering problem. How do you keep a submarine designed in the 1980s relevant in a 2026 ocean driven by artificial intelligence and digital signal processing? In the old days, upgrading a submarine's computer meant cutting a hole in the high-yield steel pressure hull, physically removing massive, custom-built military mainframes, and welding the boat back together. It was slow, and it was unbelievably expensive. So the Navy changed the rules. They introduced a program called ARCI, Acoustic Rapid COTS Insertion. COTS stands for Commercial Off-the-Shelf. Instead of relying on rigid military hardware, the Navy ripped out the old proprietary systems and installed racks of commercial-grade servers, running open-source software architecture. This means the brain of the Ohio-class can now be upgraded almost like a smartphone. When a new sonar processing algorithm is developed or a new AI threat detection software is written, they don't need a shipyard. A technician simply swaps out a server blade or runs a software patch while the boat is sitting at the pier. Combined with the massive AN/BQQ-10 digital sonar suite and towed acoustic arrays, this 40-year-old submarine has hearing that rivals the newest boats in the world. It can filter through the chaotic noise of the ocean, snapping shrimp, commercial shipping, seismic activity, and isolate the distinct acoustic signature of an enemy stealth sub creeping in the dark. And as the brain gets smarter, the fists get deadlier. The 154 Tomahawk missiles we talked about earlier, they are no longer just flying bombs with pre-programmed GPS coordinates. The Navy has integrated the Tomahawk Block 5. The Block 5 features advanced data link capabilities. It can be fired blindly into an area, and while it is flying hundreds of miles an hour over the ocean, the submarine or a nearby drone can feed it new targeting data. It can literally alter its course in mid-air to hunt down moving targets, like an enemy aircraft carrier or a destroyer maneuvering at top speed. You are looking at a stealth mothership that can deploy a drone swarm, process the battlefield with commercial supercomputers, and guide over 100 anti-ship missiles to targets it isn't even looking at. But maintaining this level of dominance requires the submarine to be out in the ocean, hunting. And the way the Navy keeps these 4 specific boats on the front lines is brutal, relentless, and pushing the very laws of physics to the breaking point.
Part 4. The relentless tempo and the limits of physics. When you have a weapon system this capable, theater commanders around the world are constantly demanding its presence. Whether it is deterring aggression in the South China Sea or launching strikes in the Middle East, the 4 Ohio SSGNs are always in high demand. But a submarine is a machine, and machines break down. They require maintenance, resupply, and downtime. To solve this, the United States Navy implemented a system designed to wring every single ounce of operational availability out of these 4 hulls. They don't assign 1 crew to a submarine, they assign 2. They are called the Blue Crew and the Gold Crew. Here is how it works. The Blue Crew takes the submarine out on a grueling, multi-month submerged patrol. When their deployment is over, they don't sail the massive ship all the way back across the Pacific or Atlantic to their home ports in Washington or Georgia. That would waste weeks of transit time. Instead, they pull into a forward operating base, places like Guam in the Pacific or Diego Garcia in the Indian Ocean. The moment the boat is tied to the pier, the Gold Crew is flown in. They execute a rapid turnover, swap command, load fresh food and weapons, and within days, the Gold Crew takes the submarine right back out into the deep. Because of this relentless blue-gold rotation, an Ohio SSGN can achieve an astonishing 70% operational uptime. It spends almost 3/4 of the year actively deployed in the water, hunting. But there is a fatal flaw in this strategy. You can swap the humans as often as you want. You cannot swap the steel, and the ocean always collects its debt. The 4 Ohio SSGNs were built in the late 1970s and early 1980s. They were originally designed for a 30-year service life. Through sheer engineering willpower and massive maintenance overhauls, the Navy extended that to 42 years.
But no amount of maintenance can negotiate with the laws of physics. Every time a submarine dives to its classified test depth, the immense pressure of the ocean physically squeezes the hull. The high-yield steel compresses. When the submarine surfaces, the pressure is released, and the steel expands back out. Imagine bending a paperclip back and forth. Eventually, microscopic cracks begin to form. In submarine engineering, this is called metal fatigue. After 40 years of diving and surfacing, the pressure boundaries of these submarines are reaching their absolute structural limits. And it isn't just the hull, it is the heart of the machine. Unlike the future Columbia-class submarines, which are being built with life-of-ship nuclear cores that never need to be refueled, the S8G reactors on the Ohio-class have a finite lifespan. The nuclear fuel is running out. The complex mechanical pumps, the reduction gears, the miles of internal piping, they are simply expiring. The Navy knows this. In fact, they originally planned to start decommissioning USS Ohio and USS Florida by 2026. But recently, the Pentagon did something that shocked naval analysts. They quietly halted the retirement plans. They are attempting to squeeze a few more years, a few more patrols, out of these exhausted hulls. Why? Because the moment the Navy officially decommissions the Four Horsemen, the United States plunges straight into a strategic nightmare, a nightmare known as the firepower gap.
Part 5. The Virginia Payload Module and the Firepower Gap. The United States Navy is facing a mathematical impossibility. When the 4 Ohio-class SSGNs finally shut down their reactors for the last time, the fleet won't just lose 4 submarines. It will hemorrhage exactly 616 vertical launch tubes overnight. More than half of America's undersea conventional strike capacity will simply vanish. In the world of global deterrence, a sudden drop in firepower is an invitation for adversaries to act. Planners call this the firepower gap, and the Navy's plan to plug that gap relies entirely on 3 letters: VPM. The Virginia Payload Module. Instead of designing a massive, multi-billion-dollar new class of guided missile submarines from scratch, the Navy decided to adapt. They took the design of the current Virginia-class fast attack submarine, specifically the new Block 5, and literally sliced it in half. They engineered an 84-foot-long hull extension, the Payload Module, and inserted it right into the middle of the boat. Inside this new steel plug are 4 large-diameter vertical launch tubes. Just like the Ohio, these tubes are fitted with the multiple all-up-round canister system. Each of the 4 tubes holds 7 Tomahawk missiles, adding 28 missiles to the submarine's payload. When you combine that with the tubes already in the bow, a Virginia Block 5 can carry roughly 40 Tomahawk cruise missiles. It is a brilliantly versatile design. Because those 4 VPM tubes are so large, they are practically future-proof. When the United States finally fields submarine-launched hypersonic glide vehicles, weapons that fly faster than Mach 5 and are simply too massive for standard torpedo tubes, the VPM will be ready to carry them. It will also serve as the perfect launch bay for the next generation of large displacement UUVs. But versatility doesn't solve the math problem. One Ohio SSGN carries 154 missiles. One Virginia Block 5 carries 40. To replace the sheer volume of stealth firepower lost by retiring just the 4 Ohio boats, the United States needs to build over 20 Virginia Block 5 submarines. And that is where the strategy hits a wall of cold, hard industrial reality. To keep pace with the retirement of older submarines and the demands of the VPM program, American shipyards need to be building 2 Virginia-class submarines every single year. But right now, the defense industrial base is bottlenecked. Shortages in master-level nuclear welders, supply chain disruptions, and the massive, non-negotiable parallel effort to build the new Columbia-class ballistic missile submarines
have slowed production. Instead of 2 boats a year, the shipyards are struggling to produce roughly 1.2. This isn't just a schedule slip, it is a strategic vulnerability. The United States is entering the most dangerous geopolitical decade since the height of the Cold War. The oceans are getting more transparent, and adversaries are rapidly expanding their own fleets. Yet, right at this critical moment, the U.S. Navy is being forced to hold the line with 4 aging, exhausted Leviathans, praying their high-yield steel hulls hold together just a little longer while the shipyards desperately try to catch up. The Ohio-class SSGN was an accident of history. Born from arms treaties and repurposed by necessity, it evolved into the most terrifying conventional shadow weapon ever put to sea. It proved that sometimes the deadliest machine isn't the one with the newest hull, but the one with the greatest capacity to adapt. But as the sun finally begins to set on the 4 horsemen, the burden shifts. The Virginia class is about to inherit a massive, heavy crown. Can the American industrial base close the firepower gap in time? Or will the retirement of the Ohio SSGNs leave a window of vulnerability that an adversary might try to exploit? Let me know what you think down in the comments. Thanks for watching. This is Future War Tech. Stay sharp, subscribe so you never miss a deep dive, and I'll see you in the next episode.